Here's the solution to example 3 using the traditional method. First, we need to state the null hypothesis and the alternative hypothesis. We are testing the claim that the failure rate is now lower, and the old rate was 5.8%. So the proportion is lower or less than 0.058, and that's our claim. The null hypothesis always has an equal sign, so the proportion is equal to 0.058. The next step is to find the test statistic. Z is equal to, but before we can continue with that, we'll have to find p hat. P hat is equal to 58 over 1520. Rounding to 4 decimal places, you should get 0.0382. So going back to the test statistic formula, Z equals 0.0382 minus the proportion that we're testing, 0.058, over the square root of P is 0.058. 1 minus 0.058 is 0.942. So Q is 0.942 divided by the sample size 1520. Work that out and round to 2 decimal places and you should have negative 3.30. If you're using your calculator to find the test statistic, you'll get a slightly different number this time. You would get Z is equal to negative 3.31. Now you need to find the critical region and critical value. So let's draw a picture. From the less than in H1, we know that we have a left-tailed test. So there's our critical region. They told us that alpha was 0.01, so that's the area in that tail. That means that the area to the right would be 0.99. Using table A2 or inverse norm on your calculator, you should find that the critical value is negative 2.33. The test statistic, negative 3.30 or negative 3.31, is to the left of the critical value, negative 2.33. So since the test statistic is within the critical region, we need to reject the null hypothesis. And now use your note sheet for the final wording. The claim is with H1, and we're rejecting the null hypothesis. So that means there is sufficient evidence to support the claim that P is less than 0.058. One more question. Does the results suggest that fewer applicants now use drugs? And you should answer yes to that, since there is sufficient evidence to support the claim that the proportion is now lower than it was before.